Unit 4 test review. Let's go. Multiply and state any restrictions on the variable. Well, I'm going to state the restrictions on the variable first. I think that's a good habit. So I look down here and I can see, number one, x cannot equal 0. I look down here, x cannot equal negative 1. Because you can't have zeros in the denominator. So that's pretty easy. Now comes the hard work. I got to multiply. So I'm just going to distribute this times this. So the 2 actually distributes through the denominator because it's really 2 over 1. Try to cross reduce. There's nothing going on there, so I got to distribute that through. So I get 2x plus 2 over x plus, and now I got to multiply this by this. And if you look diagonally, nothing cancels. If I look diagonally this way, those cancel. And so I get plus 1 over x, and semi-miraculously I get common denominators. And I say, okay, well, I can add the stuff in the numerator, so I get 2x plus 3 all over x. Now remember, your denominator doesn't change. Like 1/7 plus 1/7 equals 2/7. Denominator does not change. Number 2 says simplify and state any restrictions on the variables. Again, I'm going to do that first. So I look at this and I know that x cannot equal y. So x cannot equal y because that would cause a 0 in the denominator. So there's my restrictions. Now I'm noticing that these denominators are exact opposites. So a little trick of the trade, I got 1 over x minus y. If I just pull out a negative 1 and rearrange this a little bit, I'm going to get x minus y by just pulling a negative 1 out of this and flipping them. And I notice I've almost got common denominators if I bring this up to the numerator. So 1 over x minus y plus a negative 2 over x minus y. I got common denominators, so now I can add the stuff in the numerator. So I get negative 1 all over x minus y. Now for some reason, the book doesn't leave it here. I would leave it here. But the book shoots this negative down. So if it's multiple choice, I'm just giving you another option. Remember, negative 1 over 7 can equal negative 1/7 can equal 1 over negative 7. So this negative can get thrown around. I think they're just a little overkill here. They throw it down, and they get 1 over negative x plus y, because they really distribute it through there. And then they rearrange it, 1 over y minus x. But I think the original answer here was the best. But all three of these are the same thing. So maybe that's the best thing in preparation for like an ACT test, just knowing all three of those things are the same. All right, this next one's one of those tricky inverse variation problems. Now we got to remember this little magical formula is just sitting there waiting for us to use it. And it says, and they get a little tricky with us here, and it says P varies inversely with X. Now what you guys are used to is Y varying inversely with X. So I'm going to go ahead and do a little substitution there just so my brain can go back to what we're used to. So it says if Y equals negative 2 when X equals 6, I'm going to take that information and try to find K right away. So my X is 6, my Y is negative 2, so I know K is negative 12. Now it says find the value of P when X equals negative 12. Now the key to that is find the value of P. We've been substituting it with Y, so we don't get confused on the language they present to us. But remember, it says find the value of y when x equals negative 12. Now, a variation of this formula, if we're trying to find y, we divide both sides by x. We get y equals k, we just found that, over x. So y would equal k, negative 12, all over x, which is negative 12, and we'd get 1. which is D. Tricky little problem because of that letter P. This next problem is potentially so easy it's hard. So, which equation, so it might be 1, might be all 4, might be 2, might be 3. Which equations model the inverse variation? Select all that apply. Now, inverse variation, what we've been emphasizing is this little model equation / function. So, we have this little thing in the back of our mind that if there's inverse variation, then we've got this relationship going on. So really what you're looking for is xy. And you notice we got this. If we add 1.5 to both sides, we get xy equals 1.5. So this would be my k. But then over here I got just straight up xy equals 9. So that's for sure, because xy equals k, xy equals 1.5, which is k. And I don't have that in either of these other two. So that's a pretty simple little problem if you can kind of wade through the information. So back-to-back semi-simple problems, I think. Describe the transformations needed to translate the graph of y equals 1 over x. So there's our parent reciprocal function to the graph of da-da-da. Now, if I take this guy and I put it on the end, maybe your brain would process that a little bit better. Maybe you don't need to do that. But that was always up 2. So I can see up 2. I can get rid of that, and I can get rid of that. Now, which one of these is correct? Left 5 or right 5? Well, x minus 5 has always been and will always be right 5. So that is letter D. All right, in my opinion, some of the trickiest math problems out there. So let's see if I can explain this to you. So it says 2 robots can do a task in 5 minutes working together. The first robot working alone can do the task in 15 minutes. How many minutes will it take the second robot working alone to do the task? Challenging problem. Now, a couple of things to remember when doing these tricky problems. You can't add times. Now, what does that mean? Let's say it takes me 3 hours to change a light bulb. I know that's a silly example. But let's say it takes you 2 hours. We're both very bad at light bulb changing. If we worked together, it wouldn't take 5 hours. So keep that in mind. You just can't, you don't add time. But you can add rates. And I'm going to talk about that in just a second. So now I'm giving you another clue. The time you take and the rate you work are reciprocals of each other. Now in this particular order, the time you take, 15 minutes, the rate you work, the time you take, 15 minutes, rate you work, you finish one task in 15 minutes. So if we take this, the time you take and the rate you work, we have one job. We finish the job in 15 minutes. Now what I'm going to do, because my brain likes it this way, is I like things in terms of hours. So I'm going to say if I can do one job in 15 minutes, that means I can do 4 of those jobs in 1 hour. See, now I've got a nice clean little denominator, and that is 1 hour. All right. Now the next thing I'm about to do is to go right up here. You can add rates, but there's a twist. Here comes the twist. So this is the first robot right here. So I can take that person's rate, 4 tasks in 1 hour. The question says, how many minutes will it take the second robot working alone? That's where the variable is going to pop out. We don't know how fast that robot works. Working alone in 1 hour to do the same thing. We're going to know how many tasks that robot can finish in an hour. Now here comes the twist. Both robots do the task in 5 minutes. Well, I asked myself 5 times what is 60? In other words, how many tasks can they do in 1 hour? Well, if I divide by 5, I'd get 12 tasks. So that's what this equals right here. And if we look at this, it's like 4 over 1 plus x over 1 equals 12. Well, I mean, one way to do it is just look at it. It's 8. But wait a minute. If I subtract 4 from both sides, more mathematical way of doing things, I get x equals 8. Now, that means this robot in 1 hour can do 8 tasks. But let's pay attention to the question. So it says, how many minutes will it take the second robot working alone to do the task? In other words, one task. Well, if this second robot can do 8 tasks in 1 hour, then I take this number right here and I divide 60 minutes. So that's in 60 minutes, I'm going to divide that by 8 and find out how many minutes it takes to do one task. So that would turn out to be 7.5 minutes, which is letter B. So I know the explanation towards the end got a little choppy, but remember, this second robot can do 8 tasks in 1 hour. So we want to know how many minutes it takes to do one task. So we divide 1 hour by 8 tasks, and that's how long it takes to do one task, whatever that task is. So I hope that makes a little better sense to you. All right, number 10, the one I just did. You might want to rewind that and watch it again. These are more straightforward. It just says solve. Well, you should be in the habit of looking at what x cannot equal. In this case, x cannot equal 0. And I'm going to distribute that 2 through, so I get 2 minus 2x over 3x equals 1 minus 3 over x. Now, how do I get rid of these denominators? I'm going to look at this. I know there's a 1 there and this. If I multiply by 3x, it will absorb these variables in our denominator. So I hit that with 3x, hit that with 3x, hit that with 3x. Well, on this one, these will cross-reduce. I'm going to lightly put an x through there. I'd be left with 2 minus 2x equals, but then this hits the 1, nothing reduces. This is a minus, don't forget that. And in this case, the x's cancel only. 3 times 3 is 9. So I'm going to subtract 3x from both sides, and I'm going to subtract 2 from both sides. So now I get negative 5x equals negative 11. Divide by negative 5, and I get x is 11/5. And the book takes that to basically 2 1/5, which is 2.2. So this is correct, this is correct, this is correct, but the book went with that. See if we can squeeze this one in the last little chunk here. So first point here, second point here, find the slope. So I've already got this set up for you. Here's the slope formula. So I'd get 1 over a minus 1 over b all over x sub 2 is b, x sub 1 is a. So we got to clean this thing up. What I'm going to do here is I'm going to find common denominators. So I'm going to take this over to the side, 1 minus a, or 1 over a minus 1 over b. I got to find common denominators, so I got to multiply that by a, this by b, that by b. So I get b over ab minus a all over ab. That would reduce to b minus a all over ab. Now that right there is the top. So I look at that, and I'm going to replace that top with what it equals, b minus a all over ab. Now watch this little wrinkle. This right here, I'm going to turn into a fraction. Because if I do that, then my brain can say, hey, there's a fraction divided by a fraction, So I'm going to take the denominator fraction